All right, here we go. Hey, somebody have please number one. Number two. Let's go, Bailey.
Average rate of change of position.
We're more creative and weren't so busy in calculus. I would have made some sort of Wheel of Fortune game for all these numbers. Okay, three. Let's go, David.
Derivative.
Nice. Number four, Rachel. Nice. Please, Connor. Perfect. Number six, let's go, Aaron.
I've got a small question on
Yeah, please.
So in my notes it says that f of x width is also the df of x over dx is also the difference quotient, which is what I put on.
Let me say it one more time. Say it one more time, Aaron, the question, go ahead.
So in your notes you have, I have f prime of x is the d f of x, difference of f of x, I'm sorry, difference of x. And then that's also the difference quotient, which is also the derivative. So,
Oh, gotcha.
could I put down difference?
Yeah, any of those things would be fine. That's very good. That's perfect. It's always hard when you write a quiz like this because it's difficult to like give enough information that you know what I'm expecting.
Right.
Yeah, it's kind of tricky. What you just said is fine. Like count that for sure. What I was kind of expecting people to write here is that f prime is a symbol that means derivative. Another symbol that means derivative is this one. Another symbol that means derivative is this one. So that's what I was expecting, but what you wrote is perfect. It's totally fine. Does that make sense? Because it is a difference quotient, and it is called the derivative. So, anybody else? Number seven, please, somebody. So, Jake. Make sure you have the units. If you don't have the units, don't count it as correct. The AP test will deduct points. So, number 8. Sorry, Kenzie. Number 9. Yeah. I actually have not done these ahead of time. How many got this? How many got this? How many got this? Good. Number 10. David?
X minus y1 over x minus x1.
Perfect.
F of b minus f of a over b minus a.
Well done. So either one of those is perfectly valid. You don't have to have both, one or the other. Do you have anything else you want to ask them?
Yeah, quick question. So just clarifying, you wouldn't be able to use like the difference f of x over difference of x or the average rate of change.
Oh, well done.
right? That's-
Well done. Yeah, it's actually, it's a really good question, 2 points. It's kind of a subtle difference, okay? Like, when we calculate the average rate of change, it's between this point and this point. I'm going to show you something in a second that illustrates that when we calculate the instantaneous rate of change, it's also kind of between 2 points. But these are points that are infinitesimally close, so we come up with different symbols to make sure we can keep those separate. Does that answer your question?
Yeah.
Okay.
On number 10, put X1, 1, 6, 2.
Oh, that would be a critical error. Raise your hand if you noticed this before Aaron mentioned it. So 2 points. Yeah, don't do it backwards. Perfect. Yeah. Okay, so mark down your score. You grab the white packet. I'm gonna take some notes in there. You'll also still want to take some notes in your notebook, like the place where you write things to not forget. But we'll reference the white sheet a little bit. The first thing is a little hard to take notes on, but kind of do your best and mostly watch. So I have a bit of an interactive display here. Look at the board. No, this one's not. I can't really print this very well, right? I guess I could have, I just didn't use my bad amount. No, I'm glad you asked. As soon as you said that, I'm like, yeah, duh, I should have printed that. Nope. Just didn't think of it. Okay, look up. Okay, it's hard in calculus to say, like, I mean, how do I, the word important is often overused. And then when they say, oh, this is extremely important, that's even more overused because we'll be in a class and it feels like every single day they tell you it's important. Is that, and it's like, oh yeah, that's familiar. So I'm trying to not overuse that idea, but today's discussion really is extremely foundational. Like last time we got a bunch of terms and kind of ideas. Today we start fleshing them out in more detail, and guarantee you this. If you really will make sense of today, like you did a pretty good job of making sense of last time, it was just kind of terms and things. Today it's more like, what do the terms really mean? To make sense of them, memorizing the subsequent things is really easy. If all you do is listen casually today, like you listen to a few words, and you talk to your neighbor, and then you listen to a few more words, and you talk to your neighbor, you're going to have a hard time for weeks. I'm not kidding. Like it's really that distinct difference. If you listen super close, you ask questions, you make sense of the ideas of today, you set a very solid foundation for several days in the future. Here we go. Okay, we talked about what f prime means. We talked about that f prime is the instantaneous rate of change or the tangent slope for the derivative. I think I talked about a little bit how that actually gets computed. This little piece of software helps illustrate that a little more effectively than I did last time. So, if we're trying to find, here's a function. We'll just say that this red function is f of x. So I gotta switch panels just so I can get the right, go into right notes on this thing. 1 second. So if I go to here, grab the pen, go to red. So if this is f of x, and I want to find the rate at which f of x is changing, right here at x equal 1, that means I'd be trying to figure out, I'd like to know what f prime of 1 is equal to. F prime of 1 means the instantaneous rate of change, or tangent slope, of f when x is equal to 1. Does anyone have any question about what I just said? Perfect. The way that's actually calculated is you actually create a secant slope from point A, which is x equal 1, to some point on the right. So I've just made this point C, so I've got a secant slope to there. You're finding the average rate of change. I let the computer do the computation for me. Okay? So if I move this point, just watch it, you watch the computation change. Like it's just calculating the slope. Does that make sense?
Yep.
Okay, cool. You do the same thing to the left. So over here, and here's the computation for that slope, like so. Are you with me? Cool. Okay, to calculate the slope right at x equal 1, literally that's what you do. You find the slope to the right, find the slope to the left. And then you make these secants shorter and shorter and shorter by moving the point closer and closer and closer. As you do that, look at the two slopes. Right now they're quite different. You're about 3, about 12. But as you move, make the secant shorter, the two slopes become more and more similar. You can see it visually. Like they start to look like kind of the same line. David, please.
Will you ever get a precise answer?
Hang on. Perfect. Perfect. So notice, bring the two slopes, 11 and 8. I keep bringing them in closer. Very exciting. Okay, get the idea? I was very curious to see if I could really zoom in close. So I literally spent 10 minutes. Like to zoom on this thing, you go like this. You pull this way. Okay, I wish there was a better way. I couldn't find one. And then you pull this one the same way, like this, to zoom in. Make the scale like bigger. But every time you do that, the letters disappear, so you have to keep dragging them with you. So here's the final result of all that work. You have 10 minutes to get it to zoom properly. This is way zoomed in. Like it's so far zoomed in you lost the grid. Can't see the grid anymore. But it's the same 3 points. And it's still a secant to the right, a secant to the left. And notice the two slope values. Okay? Basically the idea is that if you get them infinitely close, they will become, like you'll see that the slope in the middle has got to be 10. That's how you find that instantaneous rate of change. Slope to the right, slope to the left, bring them in infinitely close. That's why we talk about limits. Any questions on that idea? Does that answer your question, David?
Yeah, kind of.
They don't actually ever become the same,
Oh,
but the decimals just keep getting more and more. Like it becomes 10.00000000001 and 9.999999999. So we conclude that the slope right at the point in the center must be 10.
oh, that makes sense.
Does that make sense? Yeah. Perfect. Okay, remember that. We will use that idea throughout the rest of the class. Okay, back to the white one. So let's close this. Clear that off. Go here. Okay. Clear this off. Okay, new symbol to add to your list of symbols. Okay, we talked about how if we're describing F, like, let me just get a blank sheet right here. So let's go blank page right there. So we're talking about the function F. And we said if we want to find the tangent slope of F, that's the symbol F prime. The derivative of F is F prime. The tangent slope of F is basically F prime. Instantaneous rate of change of F, that's F prime. Okay, but what we really mean by that is this is a function. It's a list of x, y pairs. This is also a function. It's also a list of x, y pairs. Let me illustrate. So go to this page now. Okay, on this drawing that you have, the very first page in the white packet. Okay, the function that is in blue on the board. I wish I could have printed yours in color, but it's too expensive. This is f of x. Go ahead and label that. So the blue one is f of x. And so we could come over here to say x equal -2. And we could identify this point. We Again, this is a bit of a qualitative analysis, so the precision is not really that important. And we could say right there that we have an f value at x equal -2, and that y coordinate is about 90. Is that fair? Question? Okay, at that point, though, there's a slope. So there's a tangent line we could draw, something like that. Not quite perfect, but we'll call it good enough. Tangent slope. Okay, f prime means the tangent slope of f. So somebody raise your hand and answer this question. Just tell me what is meant by the symbol f prime of specifically -2. What does the symbol f prime of -2 specifically mean? Think. Very good. And the tangent slope of which function? Perfect. So this means the tangent slope of f when the x coordinate is -2. So it's referring to that specific tangent slope. Everybody with me? Okay. This orange plot is a plot of f prime, which means the y coordinates on the orange plot, each of those y coordinates represent a specific tangent slope of the blue plot. So right here, somebody else help me here. What y coordinate is that approximately? Somebody just read their graph and help me out. Or hand. So Jake? About -130. So somebody else tell me, what does the -130 mean on the blue plot? What is the -130 representing on the blue plot? Brad. Please.
This isn't this is a question.
You're good. Keep asking.
Can you just repeat what you're trying to say right now?
You're doing great. So start with this one, Paris. We've got a blue function, we're calling that out. Are you totally comfortable that this dot right here has an x coordinate of -2 and a y coordinate of 90?
Yeah.
Good. Are you totally comfortable that on the orange plot, this dot has a x coordinate also of -2 and a y coordinate of -130?
Yeah.
You're there?
Yeah.
Perfect. Somebody else is going to answer the question. I think it will help you as well. This -130 has two meanings. It is the y coordinate on the orange function. The orange function is called f prime. But because f prime represents the tangent slopes of f, or the derivative of f, or the instantaneous rate of change of f, the -130 also has meaning in terms of the blue plot.
What do you mean for orange function?
The tangent slope.
No, what do you
Oh,
mean?
sorry.
Oh, no, sorry.
You go.
What do you mean it's like the f prime? Like, why is it that?
The reason that this is the f prime graph, now, I know that because I designed the worksheet. But the only way you would know that is if somebody told you. They have to say, this is f prime. So that part just someone's telling you. But what you have to understand is how these two are related, okay? Every point on f prime represents a different tangent slope on f. And the x coordinates line up perfectly. So somebody's got this. Hey. Perfect. So right here, Suganda, what's the x and y coordinate at this point?
The x coordinate?
Yeah, x and y, sorry.
Oh, it's -2 and -130.
Very good. The x equal -2 is just a locator. That means we can go to the graph of f at exactly the same x coordinate, -2, and I can write down that the slope of this tangent line is exactly, well, we're kind of estimating a little bit, but it's -130. This line has a negative slope, and its slope is a -130. That's what f prime means. Every point here is representing a slope up here. We'll do it again, I think it will be helpful, so please.
What point of the 90 on that?
Oh. The 90 up here is only a characteristic of the blue plot. It's not a characteristic of anything else. But I just wanted to show you the comparison of, hey, there's a bunch of dots on the blue function. There's a dunce of dots. There's a dunce of dots. There's a bunch of dots also on the orange function, but the orange dots have two meanings. They're just the xy coordinate of the orange function, f prime, but they're also telling you that at this x up here on f, the tangent slope will be negative 1/3. Please kind of.
So what if you took a tangent slope of the that times 1? What does that mean? Where does that
I will, the day has ended happy already.
No, that's it.
Like it won't end happier. Like I'm not kidding. Like I won't, like today, at any point when I get discouraged, I literally will think, but just think of the question that came asked. And I will feel good. Say it again.
What?
Say it
Okay,
again.
so,
It was perfect.
so if you take it,
Like, I'm just
the
gonna back.
tangent line of the function, it represents the same thing as one dot on the orange one. But if you took a tangent line on the orange line, what does that mean?
I'm just gonna bask. Like it is so perfect. Like you have no idea. Like I'm sorry, just like I just like, we should just go home. Like I'm in. Okay. So watch. So it's perfect. We have the blue function called out. Every dot on f prime has an xy pair, and every one of those xy pairs is representing some slope up here on f. You can just keep doing it forever. So I could go here and say, hey, there's a tangent slope of this function. So let's kind of do my best to draw that. So let's see, something like that. So that's my tangent line there. So that tangent slope, let's write it out here. Tangent slope of f prime at x equal -2 is. We're going to write it right here in this box. Okay. Again, as I was saying to Erica, I think it was, or Suganda in Paris, I have to tell you right now that this is out, and I have to tell you that this is f prime. Eventually, you'll learn some things that maybe you can determine it. That's not usually something that we test you on. It's like we just tell you what they are, and then you have to understand the relationship. The third one over here has a name. F double prime. The funny thing is, whenever I say F double prime, everyone goes, oh no.
Yay!
No, really. It's not quite worth the ticket, but 2 points. 2 points for Blake. Sorry, it really wasn't quite. It was very good, but it's.
It's good. I'll take 2 points.
You're awesome. This is quite the tray. I'm kind of excited.
Me too.
It's
When
really
I pull it out.
That's good. Blakely,
Yeah.
the reason I mentioned that sighing is the wrong idea is because of this. Once you understand how f relates to f prime, say it in exactly the same way. So it's not bad news, it's good news, because it means you're not learning something new. Is that fair? You have 2 points. Nice job. Parents.
Wait, so couldn't you couldn't they just go on forever? Like, circle forever?
2 points for Paris. Yes.
Points for everyone.
Perfect. No. Okay.
It's just kind of like.
Wait a minute.
Please, David.
Is this saying that it's going to be like the same slope, instantaneous slope at each point?
No, the idea is that, okay, let's keep going and then you'll see it.
Okay.
Stay here. But Paris is correct. Okay, for our class, it is not common to go past, f prime, f double prime. But as I said to Brianna, it doesn't really matter because, comparing f to f prime to f double prime is exactly the same thing as comparing f triple prime to f quadruple prime to f 5 prime, whatever you ever say that. Is it quintuple? Yeah. Please.
So could you technically using it, what you say, the side from the path, and then you use the equation on tangent slope and use that to do that way to trace a line, and then use that, and do that, and then just continue.
Oh, yes. Next unit. Well done. Super, Aaron. We're heading there, for sure. Sorry, just getting a little excited. Yeah, awesome. It's really good. Everybody with me? Awesome. Okay, cool. So, let's see. We were answering Kenna's question that we are here on f prime, we're at this point, -2 comma -130, we have a tangent slope. We just go look at the red graph now. And we say at -2, again, just kind of qualitative here. So that's the red point. So that's f double prime of x equal -2. And somebody help me there. Just read it for me. Let's go here, Kenzie. 140. And somebody else explained, what does that 140 mean? Elsewhere, Tessa.
That means on f prime, the tangent line, for the x coordinate of x equals -2, you're graphing it on f double prime at x equals -2.
You were headed perfectly, and you kind of got a little bit vague, but no worries. So you're doing really well. When I look at the red graph, this is an xy pair. And what's the x and y coordinate, Tessa? Perfect. Again, as I said to Paris, or Sagan, I don't remember which, I apologize. The -2 is a locator. It's telling you where to look, okay? So that means that we can look at f prime, because think of the word, derivative. The way I remember it is I think of, oh, derivative means derived from. So f double prime was derived from f prime. So here we go, -2 comma 140 on f double prime means that back here on this graph, that specific tangent slope at that exact same x coordinate is that number. That's the idea. Question? Please. That's what you meant, right, Kenneth? That's why I got so excited.
Yeah.
Please.
Kind of noticing that you could also reduce the shape of the next line as it goes. Because the next one start low.
Oh, you're looking at the pattern between the three?
Yeah, for
Okay.
women.
Let me make a comment on that. Two for Aaron. Hey, look.
For women, they all start high. It kind of ends high.
Yeah, there's a pattern there, but I wouldn't try to memorize that one. Just because it's not, to me, it's not worth memorizing. It's not a big enough pattern. Doesn't happen enough times that I never use. If you want to, feel free, but it's not going to happen. This kind of coincidence. So, anybody else? Awesome. We need a new symbol as well. We've got f double prime. So back here, actually, let's just put it right there. Okay. The symbol for f prime, this was on the quiz today. One of the symbols was f prime of x is the same thing as dy over dx, which is the same thing as d of f of x over dx. Okay. F double prime has a similar type symbol. It looks like this. Make sure you memorize it. D squared y over dx squared. That means the same thing as f double prime. So make sure that symbol is memorized. We're good with that. Cool. Okay, a couple of new words to learn as well. So go in the white packet to the very last page. So the white packet, go to the very last page. Can you go back? Do I need to go back to test it? No worries. Right there?
Yes.
Yeah, don't let me turn the page too quick. So speak right up. Oh, please. The symbol. It's not really important that you know where the symbol comes from. What's important is that you memorize that it means the same thing as f double. In the same way, Suganda, that f prime means the same thing as dy over dx. That's all. The symbol's a little bit weird. You don't need to worry about it. It's just, if you're super interested, come talk to me. I can show you. I have my own theory as to where the symbol comes from. I couldn't really find any definitive answer online. So, please.
So if you.
You're good. Yes, that's perfect. Listen to Dawson, 2 more points. That's exactly the idea. It's just that calculating the slope is a little bit tedious as far as like counting how far down, how far over. But literally, if we count squares on this blue line and measure the slope, we won't be exactly the same because it's hard to calculate it precisely. But if we could do it perfectly, it would be negative 130. That's exactly what it means. Is that your question? Let's do another one. Let's go over here. Go over here to 4. Somebody, let's go down here. Somebody just raise your hand and tell me what is f of 4 equal to in this problem, in this graph, I should say. Keep for hand. Sorry, just switch back to the other page for Dawson's question. Please keep
Negative 120.
negative 120. Okay, the negative 120 does not have any significance on f prime or f double prime. Got it? But if we go to f prime, right here, exactly the same x coordinate. So it's f prime of 4, 0.3, and somebody else. Let's go to Laura.
Can you put after 4 more like 1/3, negative 1/3, not yours?
Oh, I would agree. You're right. It's kind of in the middle. Yeah. No worries. Thank you, Laura. 2 more. That makes sense, Ethan. No worries. Not a concern. So this is 130. F of 4, somebody. Oh, sorry, f prime of 4. F prime of 4. Let's go here. Wait.
Negative
Oh, wait a minute. Look at a little bit closer.
2. Oh, sorry, negative 50.
No worries. The numbers are very small, and I can't figure out any way to make them bigger. So anyway, so negative 50, right? Okay, someone else, 2 for Blakely. The negative 50 does have meaning on the blue graph. What's the meaning, Rachel?
The tangent slope at x equals 4 is
Perfect. So I come right here, do my best to draw a really good, oh, that's embarrassing. Yeah, this is where I stop and I go, back to the tennis question, I feel better. Okay, good. Next one, so, that's decent. Count the squares, look. Go down and over, pretty close. We'll be a little bit off. So down, how much is each square helping? Say it. 20? So this is 20, 40, 60, 80, right? So that's 80 down. And how far is each square over? It's half, right? So this is half, 1, so about 1.5, it's about 1.6. Is that fair? Somebody take the rise, which is 80, divided by the run, which is 1.6. Somebody has a calculator, raise your hand when you have that. Did it come out exactly? Oh, no, kidding. You're kidding. That's genius. That was your question, right?
Yeah, I'm like confused on why.
It's simply because that's what it means. Yeah, no, really, I'm serious. Like f prime simply means a plot where every single y coordinate is the slope of the f graph. Now, where it comes from, we learn later. So for now, it's just just accept it. That's what it means. Please.
Why did we pick those specific points on that tangent line to go from to get the 80 and the 1.6?
Like, why did it shoot? Oh, like from here to here?
Yeah, why did we pick those
Oh,
spots?
that's random.
Oh.
I could have picked some other point and counted. I just would count different numbers, but the ratio will be the same because it's a linear line. So.
Okay.
There we go. Awesome. Okay. Other questions? Perfect. Okay, back to the last page again. This one here. The last page of the white packet. Last page of the white packet. Okay, a couple of words here to memorize. We've already learned this one, derivative. Okay, we've already memorized that means the tangent slope. So the derivative of f means the tangent slope of f. We've memorized that it means the instantaneous rate of change of f, okay? If you have a function f, and this is what Dawson is asking about, and you want to calculate the formula for the function f prime, we say we want to find the derivative of f. We want to find the derivative of f, or we say we want to differentiate f. So derivative is a noun. It's something, right? Differentiate is a verb. It's something you do. Question. You can memorize both words and their meaning. So derivative is a noun. It's a thing. The derivative of the function f, Ethan, is the function f prime. Differentiate is a verb. It's an action. It's something you do. If you have the function f, you can find the derivative of f. That creates f prime. What you're doing is you are differentiating f. Cool. Yeah. Awesome. The third one is an adjective. Differentiable. Okay, that means the function's derivative can be found, which implies that there are some cases where you can't find the derivative. Not differentiable. And it's what Dawson was thinking, it's point by point that we're talking about. So for example, back here, we talked about how at x equal -2, you can definitely find a tangent slope of f. That's why there's a point right here on f prime. So f is differentiable at x equal -2, because you can find the tangent slope at that point and create the point on f prime. Questions? Okay, counter example. Look right here at x equal -8. It's on your graph as well. If I want to find the tangent slope of that point, so this is the graph of f, I'd like to find the tangent slope right there. Going back to this one, okay? You make a secant to the right and a secant to the left. So back here, so I'll do my best to draw that. So I come over here to this side and I make a secant slope, like so. I make a secant on the left. And you're going to make those secants shorter and shorter and shorter by moving the 2 points closer and closer and closer to x equal -8. Okay, I'd like everyone in the room who can answer this to raise your hand. I'd like to really see how many in the room can understand what I'm saying. If you don't understand, just don't raise your hand. If I move this secant really short and this one really short, in this example, the two secants converged. They became like the same secant line. And the slopes became infinitesimally close to the same value. In this picture, just raise your hand if you can answer this, is that same thing going to happen or something different going to happen? Just raise your hand if you can answer my question. Or you get participation as long as you're raising your hand periodically through the class. So let's pick on Abby. Abby votes something different, and I agree. Because no matter how short I make this line, that green slope is never going to be the same as the blue slope. It doesn't matter how close those points are, it just will never be the same. How many knew that before she said it? 2 points. Kenna, please.
Is it because the one's negative and the other is positive?
Perfect.
Is that why?
And it doesn't even have to be that situation. Let me show you another one that's similar. Look at this one right here. So if we're looking at this point, Kenna, and we do a secant to the right and a secant to the left, and you bring those points closer and closer and closer, the secant on the left will always have a slope of 0 because it's flat. The secant on the right will always be positive. And it doesn't matter how close I get them, they'll never be the same slope. So it doesn't have to be necessarily positive to negative. It can be something like this. It can even be like this one. Let me draw. Here's one where, a little hard to draw, but something like that. Where the secant to the left would be a positive slope. The secant to the right would still be positive, but they're never going to be the same. No matter how close I get those dots. Does that make sense? 2 points. Here we look at the board. Look at what happened here. Look at what happened here. Look at what happened here. And don't worry about any fancy words or anything, but raise your hand, you can describe what's common. Like, what are you seeing in the graph itself? Let's make these a little more clear to see. Like, what characteristics does the graph have that's causing that little anomaly where we can't get the two secants to match? Like, how would you describe the characteristic of the graph that's causing that? That's all we can do. Just want to see how many people can kind of talk about it a little bit. Let's go, Holly.
They all kind of like a point.
Perfect. It's perfect. I don't honestly know if this is the correct mathematical word. I'm not sure I've ever read about it, but I just say they come to a corner. It's like a point in the graph. It's not smooth. Okay, and it doesn't have to be a really sharp point, but just a place where it's not smooth. Does that make sense? How many saw that before she said it? 2 more points. So the idea is this. For a function to be differentiable, because they will ask this on the AP test regularly, we've got to be able to do that little secant thing. Secant to the right, secant to the left. Okay? So to be differentiable, memorize this. The function must first be continuous. So to be continuous, you can't have a hole, you can't have a vertical asymptote, you can't have a jump. If you think of those characteristics, in fact, we can look at these pictures here. If there's a hole, none of these graphs have a hole specifically. If there's a hole, the problem is we can't find the slope at a hole. There's no point there anyway. So you can't find a slope where there isn't a point. Make sense? If there's a jump, you have this problem of if you draw secant to the left versus the secant to the right like has to go clear down to here. You can't get those slopes to match up.
So that one of these corners, why don't you just put the slope at 0 in that first example? How about they have to land on a single point?
Gotcha.
Be like 0 and
I don't know the precise answer to that. Like, one thought I had is this. If I say that this tangent slope is 0, well, the tangent slope right there is also 0. But those are two very different characteristics of the graph. So one reason we don't want to do that is because that implies that those two things behave the same. The other thing is really the definition of the derivative means you've got to do this. You've got to find the slope to the right, the slope to the left, and see if they converge. If they don't converge, we don't know what the slope
Right, if it's
is.
on a single point, you can't find it.
Right, because there's no way to find the slope right at A, because what does slope mean? Change in this minus change in this. Yep. So there's no way to find it. In fact, prior to the late 1600s, so for several thousand years, people got stuck right there. They said, hey, I want to find the slope at that point. They didn't know how. Like, I don't know how to find the slope at a point. That was Isaac Newton's great contribution, one of them. Like, Isaac Newton is really one of the greatest minds ever. He figured out that if we found the secant to the right, and the secant to the left, brought them in really close, like a limit, that we could say, oh, now we can say what the slope in the middle is. Good question, 2 points. Back to here, somebody else. So you must memorize. For a function to be differentiable, it has to be continuous. If it's not continuous, it's not differentiable. That's a hierarchical relationship, meaning if they tell you the function is differentiable, they're telling you it's continuous. Because it couldn't be differentiable everywhere if it wasn't continuous everywhere. Question. There are 2 examples, though, of where a function can be continuous and still not be differentiable. One of those we just talked about, it's a corner. So at a corner, like right here, all the points are close together. The function is continuous, but not differentiable. The other one is called a vertical tangent. Visually, that means the graph does this. Function's coming along just fine. You can find all those different tangent slopes, but then at one point, the tangent slope would literally be straight up and down. Tangent slope is straight up and down. You can't find that slope. So this is an example of a vertical tangent.
Well, that's like the slope is underlined.
Correct. And that's what, if something is not differentiable, we say the slope at that point is undefined. Like over here, two more for Kenneth. Somebody answer this. So here's a point. This is f, so I can write f of -8. Let's see, that's, help me, that 5? But I can also write this, f prime of -8. I'll just say, Ken already explained it. This is undefined. We don't know the value of f prime at -8. Questions? Please,
Why would it be undefined?
say again.
Why would it be undefined?
So somebody help him, 2 points for Connor. What does the symbol in words f prime of -8 represent? For him. Go ahead, Nick. The tangent slope of what function? Perfect. So better way to say it is it's the tangent slope of f at x equal -8. So Connor, when I write f prime of -8, I'm trying to find the tangent slope of f at x equal -8. So I look at f, I go right here to -8, and I say, if I were to draw a secant to the right, and then draw a secant to the left, would those two secant slopes ever become exactly the same or infinitely close to the same? They don't. That's why we can't find the slope there. So that's what this is telling you. If a function has a corner, you can't find the slope at that point. The slope is undefined. Please, Mary.
This might be a really weird question.
Good.
But, okay.
Serious.
Is f prime of -8 is kind of like in the limit, like if it was going to 4, it'd be like 4 minus, kind of?
To actually, this is Dawson's question as well. To actually calculate f prime of -8, you have to do a limit. Yeah, what you do is you create a form, like look at this picture. You literally create a formula for computing the slope of the line to the right. You create a formula for finding the slope of the line to the left. And then you find the limit of those formulas as the distance here shrinks. And that value of the limit is the value of that prime of 8. And since, so you've got to be a little careful, you can get it kind of mixed up between how we've been using limits elsewhere, but it definitely uses a limit. For now, that's good enough. So that's why we talked about limits. Everybody else? Awesome. Okay, next thing. Go back to this sheet here. Okay, so we talked all about f prime, f double prime. The next thing, I told you that today was extremely foundational. I'm not kidding. This relationship, how f relates to f prime, how it relates to f double prime. As Brianne said, once you understand this one, you're good, because this relationship is the same. Understanding that, looked at the AP test once. I looked at the multiple choice section and counted. There are 45 questions in the multiple choice section. I counted how many questions rely on you understanding, like how many of them require you to understand how these three things relate to each other. And I think it was like a third of the questions required that. That's how foundational it is. A third of the entire multiple choice test required this understanding that we're talking about today. So go to this page, just to get a new, fresh place to write some things down. Just the next page over. Similar example, slightly different, but similar example. So we've got an f function. We've got an f prime function. And we've got an F double prime function. Like I think you can even see on this one, Aaron, I'm not positive, that the pattern you were noticing, no, kind of similar, I guess. Yeah, these are pretty similar, but it doesn't always hold. Anyway, F double prime. Okay, follow this, please. Doesn't make sense, just speak right up. If I look at this graph in blue, this is the F graph, and I kind of go point by point along this graph. I notice that like this point, to this point, to this point, to this point, all along here the function f is decreasing. Function f is going down. Pretty good? Okay. If I were to draw tangent slopes, you would see that every one of these tangent slopes has a tangent slope value that is negative. Agree with me? Okay. That means that on the f prime graph, every single y-coordinate in that same area has to have a negative value. So here we'll match them up. Let's clear that back off again. Hold on a second. So for example, right here, put a dot. Let's straighten them down here. So there's a dot right here. Right there, the function f is going down. And down here, sure enough, the y value on f prime is a negative value. Because this slope has some negative number. In fact, I can tell you that the slope right there, that slope, at that point, is equal to about, tell me I can't see the scale, it's all blurry. What's that? Negative 27? Close enough. Again, we don't care precisely. So that y-coordinate is that slope. So since this is going down, this y-coordinate has to have a negative value. Go ahead, go ahead.
I'm just gonna get this, but like on the blue line, when you go over to the positive out 1.5 out, the blue line is still, if you go just to the left of that blue line, still goes up, but the orange is going down.
Gotcha.
Is that not affecting?
Perfect question, 2 points. What I want you to focus on right now is when the f function goes down, every single y-coordinate on f prime will be negative. The up and down of the f prime we'll worry about in a second. Good question. So when f prime is going down, every y-coordinate on f prime is a negative value. Like, look here. F prime is going down. Sure enough, the f prime value is still negative. Right here, f prime is going down. The f's going down. The f prime value is still negative. Notice looks like right about 0-ish. In fact, exactly 0. F stops going down and starts to go up. When f is, say, everyone who can see it, I want you to raise your hand. When f is going up, what can you say about the y-coordinates of f prime? All who can see it, raise your hand. When f's going up, what are the y-coordinates of f prime? And what can you say about the positive or negativeness of those y-coordinates on f prime? Kinsey? They're positive. Right here, f goes up. And while f is going up, from here clear to there, notice every value of f prime has a positive value. How many saw it before she said it? 2 points. Question? Please, Mary.
Is that always the case?
Always. Absolutely. In fact, we have a chart on the wall to help you remember it. So we call it Danica's chart in honor of the person who invented it. So Danica's chart here. So when the function f is increasing and going up, you are guaranteed that every y value in f prime will have a positive value. So when you see f going up, every y coordinate on f prime is positive. That's a positive value. It doesn't say whether f prime is going up or down, it's just they have a positive value.
Why is it prime?
It just stands for increasing. Yep. So I say going up because it's a little more common sense to just look at this and say, oh, f's going up, but the technical term is increasing. So. Anybody else? Similarly, when f is decreasing, every single y coordinate of f prime will be negative. That needs to make sense. Don't just memorize it. You won't be able to answer any questions if all you've done is memorize it. It has to make sense. Like you have to be able to look at it like we just did and say, oh, I see it. When f goes down, every one of those points has a slope that is negative. Therefore, every y coordinate on f prime must have a negative value. There we go. Please, David.
Well, why at the beginning is it the orange one going up?
Oh, okay, remember this. Going up and being positive are two different things.
Yeah.
So that's not what I said.
Okay.
What I said was, when the question, when f is decreasing, every value of f prime will be negative. So f decreases from here. In fact, you can do it this way. Watch. From here to here, every single f prime value is negative. Now, those negative values are going up. Doesn't matter. They're all negative. That means the blue line must correspond perfectly in the sense that every one of these points is decreasing. When f is decreasing, every f prime value will have a negative value. Show me where.
So to the right half, the blue line is increasing, but then the negative.
So right here, right at 4, right there is exactly the spot when f starts to go up.
Oh, okay.
So prior, f was going down. No, you got it perfect, Austin. F's going down. And while f's going down, look at every single point on the orange. Yeah, they line up perfectly. Right here, when f's going down. Actually, I did that wrong. Sorry, hold on. Yeah, a little bit sooner. F starts going down right here. Right here is where f starts to go down. Exactly when f starts to go down, that's exactly when f prime starts to have y coordinates that are negative. Over here, f's still going down, f prime still has y coordinates that are negative. Right at that spot, when f starts to go up, f prime changes to having y coordinates that are positive. Question right there. Good question. Anybody else? Perfect. Next thing. Okay, back to Kenna's comments, why it was so perfect. Okay, f and Brienne's as well. F is to f prime as f prime is to f double prime. So when you see f prime increasing, what do you know about f double prime? Positive. When you see f prime decreasing, what do you know about f double prime? Negative. Relationship is identical.
Would there ever be a triple prime?
There's no limit.
So it could just.
Yeah, the relationship just continues. And again, it's just the same relationship. So like the chart on the wall, it's the same thing I've drawn here. It's like a staircase. It just keeps going for as far as you need to. Please, right.
How did you know that out of the three graphs? Like the far right one was f of x, the middle one was f prime.
Oh,
I'm gonna
gotcha.
go the other way.
There I'm cheating because I have knowledge you don't have yet. So for now, don't worry about it. But you'll get there. So that makes sense. David, please.
So, is there any relation into the fact that, like, if just the f is increasing, does that mean f double prime will also be increasing?
Oh, awesome. Look at the chart. It's perfect. Notice there's a big blank spot here.
Yeah.
That's because you cannot draw any conclusion. So that's why it's blank. No. So when f is increasing, it doesn't really tell us anything for certain about f double prime. So just leave it blank. Please.
I was just curious if this kind of relates to the graphs when they have to do this.
It actually does. It takes, I won't explain it right now, but it's totally related. Totally. Yeah, it's the same idea, in fact. Because we talked about, remember, that we could think of f as being the position graph. Now, that's not always true, so don't lock that into memory. That this could be position, velocity, acceleration, for sure. In fact, if you understand this, drawing those charts becomes really easy. Yeah. Okay, last thing, look. The symbol right here is concave up, CU. This one's concave down. Okay? Okay, the meaning of concave up, memorize this. Concave up means that the tangent slope point by point, that's really key, that idea of point by point. Tangent slope point by point is increasing. That is the definition of the word concave up. Somebody got tired of saying all those other words, they invented a word, concave up. Question. Memorize that. Concave down is simply the opposite, so memorize that as well. Okay, visually, concave up is simple. You've studied this before. Concave up is this shape, right here, or any part of that shape. I've heard a lot of other definitions. I've never heard one that's better than that. Concave up is that shape or any part. So go. Right here.
Yeah.
Oh, let me explain. So here's the difference, Sugan, and everyone, like, really focus on this hard. Focus, everybody, eyes up here. Come on. Okay, right here, F is definitely decreasing. But F decreasing just means that the Y values go down. Okay? Concave up is different. Okay, this shape is definitely concave up because it's this shape, or it's at least part of that shape. So that means the slope, point by point, must be increasing. So right here, just say it out loud, please. Is the slope positive or negative? Say it. The slope. Is the slope positive or negative? Negative. Look at the F prime graph. The dot down here is a negative value. Look at the next point. Negative. But look at, is it more or less negative than the previous? Less. That's why the Y coordinate here is going up. So those Y values are negative. The slopes are negative, but they're becoming less negative as we follow the curve. That means point by point, the slope is increasing. The function's decreasing. The slope is increasing. That helps you go. Yeah, please.
Okay, so when you go to the f of x line where it is in the concave up shape, wait, go further. Yeah, right there. That's the full shape. How would you compare that then to this?
Perfect. So, okay, watch close. I'm going to put pay tickets at the start of class again next time. Everyone listen close. We've got 2 minutes. Okay, I don't want you to get the wrong idea. We don't have homework tonight. We'll have a quiz again. The reason we don't have homework is this. Look at me. Okay, you have to learn calculus from a big idea perspective. If you try to learn it like little idea homework, it's a disaster in my opinion. Because you don't connect the ideas. So that's why we get the big ideas, we talk about it, then we can start doing problems. So anyway, back to Kestis' question. Focus here hard. I'll pay tickets to start the class next time. Look right here. Okay, this is actually super helpful. When F changes from concave up to concave down or vice versa, how does F prime have to change? Look at the chart. Somebody say it. Increasing to decreasing or vice versa. How does F double prime have to change? Positive to negative. That means the Y values must change from positive to negative or vice versa. So if I look at this graph, I can see perfectly when all of that is happening. Because right here, F double prime is changing from negative Y coordinates to positive Y coordinates. And precisely at that X coordinate of about 2.9, that's exactly when F's going to stop being concave down and switch to being concave up. It's also exactly when the Y values of F prime are going to stop going down and start going up. Was that your question?
Yeah.
Anyway, did you see the relationship? Don't talk. Hey, quiet. Quiet. Don't talk.
Is it always halfway between the concave up and concave down when it switches?
Oh, it's actually a little bit difficult to look just at the, everyone look at this. Look, don't leave on the belt. This is perfect. It's a little difficult to look just at the blue and say, where is the concavity switching? That's not super easy. But if you have the f prime graph as well, it becomes really easy.
Okay.
Because you just say, hey, when f prime changes from increase to decrease or vice versa, the concavity of f will change. So I can follow the orange graph and easily see that right there is the switch from decreasing, and that's where it changes. Perfect. Good job, you guys. Well done.
Thank you.
Well done. Good day.
Right when he started doing that.
I just use those as the to me, there's no better compliment that I could ever hear from a student. Serious.
Yeah.
Serious. Like, if Pat was like that, then it's you're doing it right. Because that means your brain is just like fully locked in. You know what I mean? There's no reason. Wait a minute. They just, honestly, to me, that's the kind of job that that has only 30 seconds. First meeting, like I would go off and keep working. Everyone get here. It's time to eat lunch. Yeah, that's what you want. Oh yeah, that's the like it's very serious. Like, you ask that question. That's what this job. It's like I don't know.
Transfer to my class.
Oh, right. It's really good. Grades over.
Transfer into normal English for
So, like,
then you come here and go.
so I actually worked for Exxon for 2 years. That's the oil company. And then this Bowl and Boys projects I worked on in a company in Kobe, it's really small. It's really and we built and sold. All right.
Since I was absent, you have your shoes.
Gotcha. So the preparation part, I kind of just give you the benefit of the doubt when you miss. And as long as you get the assignment done, we'll just assume you remember that. Does that make sense? As far as getting the assignment done, really, you just need to make sure, this is really you and I together. You just got to make sure you get it done fairly quickly. Because falling behind is the worst in this class. Some classes, it doesn't really matter. This one is critical.
Yeah.
So I don't have a firm deadline. I just want you to think, okay, based on my schedule, how quick can I get caught up?
Well, I'm done.
Oh, let's go type it in. So, yeah, that's all I care.
Okay.
People who come to me, long time later, I'm like, you're really hurting yourself. It doesn't matter to me, but so I have, we have to have some kind of penalty if you wait too long. Otherwise, you kind of lose interest in
Yeah,
staying
that
up.
definitely
Does that make sense? No, you're fine. Let's get it typed in.
Do I need to get it out?
No, I told you before that to me this class won't work unless you're honest anyway. So.
Okay.
So basically, have you finished the
Yes.
Good job.
Thank you.
Yes.
So if I stay after today, can you go through the lecture on Monday and all the terms in the packet?
Oh, so same thing. What you want to do before you stay after is if you watch the videos. Yeah, did you watch the video?
I'm going to watch it after I finish my bio lecture.
Oh, very good. So yeah, watch the video. And once you watch the video, as you're watching it, if things pop to mind, you're like, hey, I don't quite understand that or this
Can I
or whatever.
take note of it?
Oh yeah,
Okay.
for sure. Then you're totally welcome to come in after school and just ask whatever you want to ask. Yeah, as long as you've done the video first, because otherwise it's kind of too much.
Yeah. All right, thank you.
Good job, Krista. Another thing I have noticed based on kind of how I teach is it does vary from student to student. That some people have pretty good success. They'll like watch the video. In this case, there wasn't an assignment, so you can do it either way. But some people it works pretty good to watch the video and then just keep coming to class afterward. And then when we start doing an assignment, they'll come ask questions. But either way is fine.
Okay.
It's up to you. So hope you feel better. Look like you're suffering. So.
I haven't been like sick enough to miss school in years, and I'm like there now, and I'm kind of like,
You're like me, I hate to miss, so, all right, good luck, Gusta.
Thank you.
Good morning, Mike. This is Haley Bennett and Maddie Sigmiller. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag FPLA meeting during lunch every Wednesday, meeting room 800.